We are live. Welcome to another episode of Business Focus Live with me, John, where we talk about topics that help you help your business achieve your goals. If you're new to this channel, don't forget to subscribe and let's get started. And we're back. Welcome to all the viewers today. If you're new to this channel, as I mentioned before, don't forget to subscribe. Today's topic will focusing on more discussion on hypothesis testing. Now, before we proceed, let's see who's online today. Everyone. So, before we proceed with our main topic today, we'll be discussing some other stuff. First and foremost is regarding the hello, Kyla. So, first is regarding quiz 2. So, I hope everyone's already viewed their quiz 2 results. Now, if you have any further questions or clarifications, don't hesitate to email me. So, just email me directly, then I'll get back to you as soon as possible. And as I mentioned, I've already included the incentives for quiz 2 and quiz 3. Now, regarding the quiz 3 results, I'll be able to send you later on the answer key so that you can double check if there's any questions or clarifications. Sorry, quiz 2 result. For quiz 3, which we will have it by next Thursday. So once we finish today's topic, if we need to add another session by next Tuesday, we can discuss it later on. As for the coverage for quiz 3, we'll be covering 3 topics only. So from our last discussion, which is 2 population means, today's topic on ANOVA or analysis of variance, and finally, last topic is linear programming. After quiz 3, I got some good news for everyone. We just had a departmental meeting earlier, and it was decided that there will be no more FANS exam for this particular subject. So in place of that is we'll be utilizing the other criteria. Now, as to the breakdown of the grading system, I'll update everyone once it's been finalized. So, which leads us to our next part, which is your assignment. Now, we've discussed earlier that I've given you 2 alternatives. So, first is do the original survey for family-owned business. If you have difficulty of conducting that, you can do the alternative case study as I mentioned before. Now, I also can give you a third option. Now, if you cannot do primary collection of data for your family business, I can give you, I will allow secondary data. So as long as you collect at least 30 sample size. And then the options D will still be remain, meaning if you prefer not to do the primary collection of data or secondary data, you could still do the case study, which will be required to be submitted by end of the month. So I think our online class will end by first week of May. I think that's the date. So don't hold me on that. I will check on that one. But as of the requirements, you have until end of the month to submit all of it. So we'll finish our discussion. Hello, everyone. Hello to everyone. I hope everyone has already taken their lunch. Where was I? So as I mentioned, so we will have until next week to finish everything, meaning discuss our topics and have our third and final quiz. So if you have questions, you can drop your questions later on, so I'll get back to it. And finally, before we proceed, so one more thing. So regarding the feedback, now, I've already asked you this before, but not everyone's able to give their feedback in terms of what option do they prefer. Is it option A, B, or C? So for today, can I get everyone's cooperation and send their email regarding what option do they prefer? Was it A, B, or C? Because if you chose option C, meaning you cannot participate in the online learnings, then there will be other accommodations to be provided, which will be discussed in another meeting. So I just need first your feedback on what options you preferred with regards to the updated situation. So there will be no more finals exam. So then what would be more advantageous to you, then you can consider option A, B, or C still. So it does not matter. Okay, so I think we can continue. Good afternoon, everyone. Okay, so As I mentioned, our main topic today is we'll be focusing on hypothesis testing. So as mentioned, just to go over some of the things that we have mentioned before, there are four steps involved in conducting hypothesis, regardless of what type of test you will be conducting or types of how many groups that you have. First and foremost is develop the null and alternative hypothesis. Is it based on research, claim, or decision making? Since that will have a detrimental effect in your conclusion later on. So step two is determining your level significance or your alpha, which is based from your confidence level, which has three folds. Typically, it's 90%, so that's 0.01, sorry, zero point 0.1 level significance. 95% confidence level, which is equivalent to 0.05. And then 99% confidence level, which is equivalent to 0.01 level significance. Step 3 is key also. Once you've determined the steps 1 and 2, step 3 will be determined by conducting the test statistics. So you have four options here. Is it a z-test, t-test, f-test, and chi-square test? So we already discussed conducting z-test and t-test if it's based on one or two population need. For f-test and chi-square has other applications. So today we'll be focusing more on the f-test using for analysis of variance, ANOVA, or for linear regression. And then fourth and final step is conclusion. So to make it simple, we use the p-value approach, meaning we compare what is your p-value in relation to your level significance. If your p-value is less than equal to your level significance, we reject the null hypothesis. If it's false, we do not reject the null hypothesis. Okay? Hello, Colin. Print bold, huh? Anyway, so let's switch our screen. Let's go to the first example here. Let me take a look. Okay. No, not this one. What is this? Nope. Is it this one? No, the wrong example. So let me try to change the window for a while. It's this one. There you go. So in hypothesis testing, so we've already discussed before, what if we were to test based on one population, so you can conduct z-test or t-test. Same goes if it's for two population or two groups. So what if you were able to have more than two groups beyond that? What are our options or alternatives? So this is where analysis of variance comes in. So if you have more than two groups, you can conduct analysis of variance. And the advantage or the utilization of analysis of variance is you have only one type of hypothesis. So meaning you're just comparing if the means of each group are similar or not. That's it. So you don't have to worry if it's greater than equal or less than equal. So the primary objective of analysis of variance is to test the significant difference from the different groups. So in this case, we have here an example. So let's say you have a business that sells retail products. So let's say you have 3 stores here, like in this case, stores 1, 2, and 3. And in each store, you have 5 salesperson. So each salesperson are able to generate sales on a particular period on a particular day. So let's say store 1, salesperson 1 was able to sell 48 units. And salesperson 2, 54, and so forth and so forth. So what we like to find out based on the performance of each stores is their performance in terms of sales similar to one another. So normally we would get the average, get the descriptive analysis first to find out whether they're similar or not. So let's do that. So sample me. So let's type in average and select entire column. So for store 1, it says that the average sales is 55. So if you were to copy and paste the rest, so we can see for store 2, it's 68, and then for store 3, it's 57. So based on observation, you can see that 55, 68, and 57 is different from one another. So you can try to conclude that they're not similar, but that's just based on descriptive analysis. So to dig deeper, we will test if indeed the 3 groups are similar or dissimilar from one another. So to do that, so let's go to the next part. So as mentioned, so the hypothesis for analysis of virus is very simple. Your null hypothesis is stating that the different groups or different means in this case are similar. That's why it's equal to. So the minimum criteria or requirement for conducting ANOVA is at least 3 or more groups. And then for the alternative hypothesis, it states that they're not the same. Simple as that. And then for the test statistics that you'll be conducting later on is using F-test. Now don't worry about the computation. We'll be using Excel's data analysis to do the computation for us. So it simply states to solve for the F-test, we need the mean square treatment divided by the mean square error. Finally, we can determine the conclusion. Okay, so to do that, we need to go to Data tab and select Data Analysis. Now, for those who want to know how to enable data analysis, you can check out my other video on how to enable data analysis. Once you've done that, select regression here. Sorry, not regression. Go to ANOVA, it's in the first part. So if you notice here, you have 3 options here. ANOVA single factor, ANOVA 2-factor with differentiation with replication and without replication. For our purposes here, we'll be using the single factor. So what does single factor ANOVA means? We're only considering one factor as your comparison. So in this case, we're trying to compare the store's performance as a whole, whether store 1, store 2 versus store 3. Okay, so let's select ANOVA single factor. Once you've selected, you'll be introduced to another window. So you'll be asked to input the input range. So only select that columns store 1, store 2, and store 3. Once you've done that, select enter. Make sure it's grouped by columns, not rows. And then check the box for labels. And then your alpha is your level significance. No, as I mentioned before, if there's no assumption provided in the problem, we always use 95%. So in this case, it's 0.05. And then on output range, let's display it at the same page so we can see the result right away. And select OK. Okay, so let's move here to the side. Sorry, let's move here to the side. So you can see here the summary result of your ANOVA table. So this is the entire summary. So there are 2 tables that we need to take note of. The first is the summary, meaning your descriptive summary. So you can see here you have the groups here, different groups, store 1, 2, and 3, and the count has 5 sample size, the sum, and the average. So you can see here it's the same one that we did early observations of. So you can see that they're different from one another. So we're trying to test if they're similar or dissimilar from one another. So for variance, they're somewhat close to one another. So as mentioned again, to test whether they are similar or not, we conduct the F-test, which can be located in the second table, which is in your ANOVA. So normally, if you were to do this manually, you have to solve for the sum of squares, degrees of freedom, mean squares, and then solve for the F-test. In our case, we already have the F value, which is 9.5 or 9.55. So once you have that, you can now solve for the P value, which in this case they already have. So our P value here is 0.003, which is less than 0.05. So based on that P value, we can already determine the conclusion. So if we were to compare our P value, which is less than 0.05, our conclusion is to reject. So if we were to reject our null hypothesis, what it means that the mean of 55, 68, and 57 from the 3 different stores are not the same. Right? Were you able to get it? That is fine. Any questions so far? Okay. It's already afternoon. So good afternoon, everyone. So let's continue. So as I mentioned, once you have tested it, so we were able to confirm that all 3 are not the same. Now, if you were to dig deeper, which of the 3 are dissimilar from one another? So if we were to go back here, as mentioned, average for the 3 different groups. Now, obviously, by observation, you can obviously see that store 2 is different from store 1 and store 3, while store 1 and 3 are similar to one another. That's just based on observation. But we could also test this using the Fisher's least significant difference. But we won't include it in the exam anymore, but it's just for our discussion today. So how can we identify if which one is dissimilar, since in our case, we were able to test in our single factor that they are dissimilar from one another. So you compare the two groups at a time using the LSD, or least significant difference value, which was in this case, I think it was 7, and then compare if it's greater than equal to the difference of the absolute value between the two groups. So in this case, let's use the example of store 1 and 2. So 55, absolute value of 55 minus 68 is 13. So your LSD is less than equal to your to 13, so they're not the same. If you compare store 2 and store 3, so that's 7 is less than equal to 11. So they're not the same. And if you were to compare store 1 and store 3, so that's 6 is less than equal, greater than equal to 2, they're similar. So which gives us already an insight that based on using the LSD, you can find that store 2 is indeed different from store 1 and store 3. Okay? Okay, thank you for your feedback. What else? So let's go to another example here. So apart from using one single factor in ANOVA, as you can see in the options in the data analysis, you had replication and without replication. So this pertains if you want to include another factor, meaning two factor in your testing. So let's use another example to illustrate the problem. Okay, so here we have another example. So let's say you have a manufacturing firm and you have 3 different plants that produces certain type of product. So you have 5 machines here that produces at different rates. So for example, at plant 1, machine 1 can produce 31 units, machine 2, 30, machine 3, 29, and so forth. So in your other plants produces different rates. So what we'd like to find out is whether the production or the average production is similar to one another. Now we can do that. So I've already did the computation here. So the mean for plant 1 is 29.8. For the second one, it's 28.8. And for plant 3, it's 28.4. Now, just by simple observation, you can debate whether they're similar or dissimilar from one another. So if you were to normally test it, we could use single factor to test this. So we could do that right now. So again, so to repeat the process, go to Data tab, select Data Analysis. So use single factor, analyze single factor. So make sure to include the heading, okay? And then check the box for labels. So let's output on the same page. Let's put it here. Okay. So we have the same result. And if you were to look at the p-value, so you can clearly see it's greater than, it's not less than 0.05, meaning, what do you mean? So we do not reject the null hypothesis, which means that they are the same. Okay? So if it's the same, there's no need to do further testing, whether if they're dissimilar from one another or not. But how about in the previous problem? So let's go back to the first problem here. So we were able to confirm here that they're similar to one another. So let's use the two-factor analysis here. Two-way ANOVA analysis to test if it indeed is similar or not. So let's use the two-factor without replication here. Okay. And then in this case, instead of just encoding the 3 columns, you have to include the first column, which is the second factor, salesperson in this case. Then select enter, check the box for labels, then the alpha is still 0.05. Then let's display the output here on the same page again. And select OK. Okay, so we can see here we have the same result, 2 tables, the summary and your source of variation. Hello, Ms. Capopes. So let's focus first on the summary output. So again, you can see similarities in the one-way table. You can see the summary for the groups for store 1, store 2, and store 3, but with the addition of the row component, meaning you do an average for the each row in for each salesperson regardless of store 1, 2, and 3. So we can see here that for row 1 or salesperson 1, the average is 57, row 2 is 60, row 3 is 61, and row 4 is 57 and 64. So you can see here that their average per employee somewhat varies from one to the other. So can we conclude that they're similar or dissimilar from one another? So using the two-way ANOVA, we look at the p-value here. And you can see here that the p-value here is less than 0.05, which simply means that they are not the same or they're the same. So you reject the null hypothesis, meaning that they're all the same. So meaning the difference in a two-way ANOVA is different from the result from the one-way ANOVA. So the advantage of using a two-way ANOVA is to take into account the row component, in this case you're blocking. So you might, what do you call this? You might assume that just using a simple one-way ANOVA will do the trick and give you a different result. So to be more precise, you can factor in a second factor, in this case the sales people, meaning the stores alone is not enough to determine if they're the same or not. So it's important to know also who's the salesperson within the stores that have an impact in the sales outcome. Okay, so any questions so far regarding the discussion? Let's see some feedbacks. Any questions so far? So anyway, any questions regarding the discussion, the few things that I discussed earlier regarding quiz 2, quiz 3, the assignment, as well as what else? Yeah, the assignment. Yeah. Any feedback so far? Anyway, so I'll wait for your comment later on so we can proceed with our next topic. So after doing analysis of variance, if you notice, so if you have one group, you can do z-test or t-test. Same for two groups. Now, if you have more than two groups or two population, you can use analysis of variance here. And finally, we'll be discussing linear progression. Linear regression and regression. It's okay, Jerome. You can review the... Yes, it's from the data analysis. You can always review the stream later on. So if you have if you miss any part of this discussion, you can always go back. That's the advantage of this stream. And this is recorded. It's okay. Okay, it depends on the problem. So obviously in real life, you have the prerogative to choose whether to use single or two-factor. But for our purposes here in the exam, it will be stated. So actually it's given in the problem. If it gives you two-factor what do you call this? Two-factor scenario, then you have to use a two-way ANOVA. If it does not, it only gives you one factor, then you use the single factor. If it's not stated, otherwise it would be stated either way. So don't worry too much about it if it's one way or two way. You can always ask to verify. Okay, so again, let's go to the next one. So our next topic is linear regression. I was gonna say linear programming, that's for another class. Anyway, so what is regression all about? So if you notice, what we've been doing so far up to this point is discussing comparing means, if it's similar, dissimilar, if it's greater than or less than. So more often than not, when you're talking of variables, like in our case, so you're talking of business performance, so sales is always an important factor for any business or profit. So what affects sales? What affects profit? So we're trying to find relationship in different factors or different variables. So let's say profit, what affects profit? So profit is affected by your sales in terms of your expenses. So the higher the profit, the higher the revenue, the higher the profit. The higher the expense, the lower the profit, and things like that of nature. So what we'd like to When regarding the alternative assignment, as I mentioned, so you have three choices. Still do the survey for the family business, which is primary data, or you can do secondary data. When I say secondary data, meaning you can choose any data as long as it has at least 30 sample size and do the analysis uh, uh, similar to the one I mentioned in the case. And then third and final, if you think that you cannot do both, still you can do the case analysis. So do the alternative case study. So you have three options, but you have to choose one and submit it by end of semester, which is by end of the month. I hope that clarifies it. Anyway, so going back to my discussion. So as mentioned, so when you talk of regression, you're trying to find relationship between variables. So which leads me to the next part. So what are the components in regression? So there are two main parts or two main components, your independent and your dependent variable. So when you say independent, that can stand on its own, that doesn't rely on other factors, while your dependent factor is, as from the term itself, it relies on other factors. So the good example is sales. So sales is considered a dependent factor where it relies on other factors like revenue, sales, expenses, and many more. So like in your case, grades is a dependent factor because grades of students is reliant on several factors: exams, requirements, presentations, and class participation and whatnot. So those are the two main components, and I will show you later on how to use Excel's data analysis to illustrate the example. Yes, consideration will be get if you're able to exceed 30. So that's why I only mentioned that you need at least 30. Obviously, if you get more, you get better result in your analysis and you'll be given extra credit for doing the effort. Okay? Yeah, I know it's difficult times. That's why you have to be flexible in this time. That's why if you have any concerns at any point, do let me know right away so we can make the necessary adjustments. So we have the forum here and you can always send me an email. Worst case scenario. Okay? So let's go to the example. So to better illustrate. So, where's the other problem? Let me see. Okay. Sorry. Okay. So here we have an example here. So if you were to take a look here, so you have three columns here. So let's say you have a business. Okay. So you own a business that has different retail stores. So you have, let's say, 5 stores nationwide. And then within those stores, you have different salesperson. So in this case, let's say store one has only one salesperson, another store has three, another store has two, another has one, and the fifth one has only three. And then based on that store, it generates different sales or revenue. So what you'd like to find out is the salesperson affect your sales, the number of salesperson in this case. So we can use regression here to find relationship here. Okay, so to do that, we will use data analysis here. So to do that, let's go to data tab. Sorry, before we proceed. So let me explain first the hypothesis involved. So it's still the same process before, but the hypothesis is very simple. There's only one, similar to ANOVA. So here we're trying to compare the hypothesis if it's equal to 0, and then if it's not equal to 0. Now, if you notice here, this is not D, this is beta, or the estimated regression. So meaning the estimated regression here, meaning the relationship between number of salesperson in sales, is it equal to 0? Now, can anyone tell me what does the 0 imply here? So again, we're talking of relationships here. Any ideas as to what the 0 is implied here? So when you say 0, if you recall, when you're talking of description or relationship, it's how strong, how weak the relationship is, right? So if it's closer to 1, it's strong. If it's closer to 0, it's weak. Now, if it's exactly 1, there's a perfect relationship. And if it's 0, there is no relationship. And that's what we're trying to test here. So in regression, we're trying to test if there is a relationship between said variables or if there is not. That's why it's not equal to 0. If it's equal to 0, it could be greater than 0 or less than 0. Okay? And the test statistic that's conducted here is F-test still, but with a different formulation. So MSR, or mean square regression, divided by the mean square error. But we'll not go into the details of how to compute for. We'll use Excel's data analysis to do it for us. And again, for the conclusion, we'll use the same assumption for the p-value approach. Okay, so let's go to the data tab. Go to data tab, select data analysis. Okay, and look for regression and select OK. Now here you'll be asked to input two things first, your input Y and your input X range. Now take note, when you say input Y, this pertains to your dependent variable, and for your input X, this pertains to your independent variable. That's why it's imperative to understand first the problem or the premise of the situation, which variables is which, so you don't confuse one over the other. Otherwise, you'll get a different result. So for our purposes, as mentioned earlier, we want to test whether salesperson, the number of salesperson, can affect your sales. So that's our primary objective here. So for our dependent variable, so let's select the sales column. So make sure to include the heading. Okay. Then for the input X range, let's select number of salesperson. Okay. And then make sure to check the box for labels. Otherwise, Excel cannot recognize your heading sales and salesperson because it's qualitative data. Okay, and next is select the output range. So let's use the same page so you can see the results right away. Then select OK. Okay, so we have it here. So if you see here, there are 3 tables presented here. So we'll go by it one by one, so it will be clear to everyone. So let's start first with the regression statistics. So yes, no, not necessarily, not the non-negativity. That's for regression. That's for linear program. That's another topic altogether. But when you say 0 in the regression, it means there's no relationship. There's no connection between one another. So is it possible that a number of salesperson has no connection to sales? It's possible. That's why we're trying to test it. So the next part here is we're trying to describe the relationship here. So if you recall our discussion in our first topic, which is descriptive statistics, we have already discussed parts of this already. So let's take a look here. So if you notice here, multiple R is 0.93. Now, does anyone know what multiple R is? It describes how strong or how weak the relationship is between two variables. What do we call that? There's another name for it. Can anyone tell? So that's the correlation coefficient, if you recall. Yes? So multiple R is the same as correlation coefficient. So it tells us here, it describes that the relationship between salesperson and sales has a very strong and positive relationship. Now, the second value that we can look at is the R square, or the coefficient of determination. So it shows here how strong of an effect salesperson here towards sales. So 0.87 here tells us it has an 87% impact towards your dependent variable. So it's all descriptive. So it's pointing towards a very strong relationship. Now, question here is, can we conclude that there is definitive relationship between salesperson and sales? So we can find that out in our next table, in the ANOVA table. So that's right. So it's this one. So as mentioned again, we need to determine the F values, which we already have, and find the P value. So you can see here, the P value is the same as your significant F. So let's highlight it. So you can see here that the P value here is less than 0.05. So if it's less than 0.05, so what will be our conclusion here? So our conclusion here is to reject the null hypothesis, which means that they are not the same. Not the same. So it's not equal to 0, meaning they have a relationship. Okay? So simply put, when you say equals to 0, no relationship. And then if it's not equal to 0, has a relationship. Simple as that. Okay? So you can do this in many ways, especially when you do your thesis later on. So more often than not, the methodology that you'll be applying here is quantitative, and more often than not, you're trying to test relationships here. Now, obviously, there are different applications. So apart from linear regression, there's also what we call multiple regression, where we factor in multiple independent variables that has an effect, has or no effect to the dependent variable. Good example is your student's grade. So student's grade is considered dependent variable, and it has other factors that affects it. So from exams to class participation, group participation, presentation, group projects, and past exams, and so forth. So are all of them significantly affecting your final grade? Maybe, maybe not. Maybe some of it, maybe none of it. So that's the whole point of regression, to identify which is significant. Typically, we do this in research. That's why in your thesis, you'll be doing this often. Okay. So, questions so far? Let's go back to our chat room. Yes, it's the multiple R is also the same as the correlation coefficient. They just use different technical terms. They're one and the same. And so if you notice here, we didn't even use the scatter diagram to illustrate the relationship. Correlation coefficient is a more precise way to describe your variables, whether it's strong or weak, positive or negative. Okay. So could use an example to better illustrate our problem here. So were you guys able to answer the exercises I gave you earlier? Or before, sorry, not earlier. Before, in particularly the ANOVA exercises. So let's see. Let me go to the other one. Okay. So let's switch to the different window. Experiment. There you go. Okay, so I think I already sent you this before. No, beta is not the same as alpha. The beta that you saw in the hypothesis, it pertains to the estimated regression equation, meaning the y is equals to mx plus b, meaning it takes into account the independent variable, the dependent variable, the slope, and the y-intercept. So the main point here, what you're trying to test here is whether the independent variable has an impact or effect towards your dependent variable. That's it. Okay. It's okay. So if you have any questions, feel free to post your message. Okay. So let's go to the examples. Oh, did I only send LP problems? Okay, it's okay. I'll try to send it again later on, but we'll try to answer it now. So let's try to answer the first problem here. So experimental design analysis of variance. Okay, so here we have the first problem. If you were to take a look here, so there are 3 different groups. So obviously it gives you already an idea what type of ANOVA you're going to do here. So you'll be using analysis of variance one-way factor. So there's only one factor, meaning the groups or the columns. So to test this, so again, go to data tabs, go to data analysis and select single factor ANOVA. And select the columns. Make sure it's grouped by columns and then labels, alpha, then let's display it beside. So let's see what's the result. Select OK. Okay. Can we see the result? Okay, so we have here. So let's take a look here. Let's look at the average here. So based on descriptive statistics here, the average are somewhat different from one another, ranging from 134 all the way to 156. So it varies by almost more than 20. So if you were to test this, will it yield, would it be the same or not the same? So based on observation, it's already telling us that they're not the same, right? So based on our p-value here, since it's less than 0.05, what does it tell us? So if it's less than 0.05, we reject the null hypothesis that they're not the same. So we were able to observe that they're not the same, and we are able to conclude by testing using the ANOVA. Now, were you able to get it? So let's go to another problem here. So let's see here. Yes. Okay. So in our next problem here, let's type the operator. Okay. So obviously you can see here it's a two-factor problem or two-factor ANOVA already based on the rows and column component. So if you were to do descriptive analysis, so let's get the mean for each column. So 16. So again, so just based on observation, is 15, 16, 21 similar or dissimilar? You can debate it that they're similar, somewhat close, maybe somewhat different as well. And how about for the row component from the different operators? So you can also get the average. Copy the rest. So you can see here also that the average here for the row component is somewhat different from one another. So if we were to just test the one-way factor, let's see what's the result. So let's do the one-way ANOVA. See what would be the result. Okay, sorry for the noise outside. Okay, so let's display it here. Display below and select it. Okay. So if see based on the one-way single factor ANOVA, it's less than 0.05, meaning that they are not the same. Okay. So based on the means that 16, 15, 21, they are not similar to one another. Okay, now if we were to use the two-way ANOVA without replication, let's see if we get the same result. So in this case, not only do we select the columns, but also the row component. So in this case, the operator. So once we select that, check the box for labels. Let's level significance, the output. Let's display it below. See what's the result here. Okay, and select OK. Okay, so let's focus now on the ANOVA result. So you can see here, so your P value here is what? So if you notice, is it 1.9? If you notice there, it says E minus a negative 0.5. So E stands for exponential. So it's raised to the negative 5 power. So meaning, do we move the decimal to your left or to your right? So in this case, you move it to the left. So no need to count. So the point here is it less than 0.05? So based on the result, it's less than 0.05. So we conclude that they are definitely not the same. So based on observation, it confirms that they're not the same. From one-way factor, it confirms that they're not the same. And for two-way factor, it also confirms that they are not also the same. So that's how we use analysis of variance. Okay, any questions so far? Okay. So let's do one more problem on linear regression before we conclude our today's session. Let me switch the window. Where is it? Hypothesis. There you go. See this one? Nope. This one. Okay. So if you notice here, the first problem in linear regression here, you can see that it's laid out like this. So you have to change the layout, otherwise Excel cannot understand that. It can only recognize if it's selecting data per column basis, not per row basis. So we have to realign this and copy it. Either copy it or change the alignment. So X is here, Y is here. Then we can copy the value. So that's 1, 2, 3, 4, 5. Then for our y dependent variables, 3, 7, 5, 11, and 14. Okay. Now, obviously, in this example, it doesn't state what the independent dependent variable is, but the assumption here is the x sub I represents your independent, and your y sub I represents your dependent variable. Okay. So let's try to test the relationship if the x has an effect or impact towards your y variable. Right? So let's go to data tab, select regression. So once you've selected regression, select OK. So for our dependent variable, okay, so it's y. And then for x or independent, it's x similar. Then check for labels. The output range, let's display it below, or beside, sorry, and select OK. So if you were to look at the descriptive summary here, so your correlation coefficient here, it says that they have a strong relationship, near perfect relationship at that. And for the correlation determination, coefficient determination has a very strong effect also. So your x variable comprised of 84%. If you notice here, if it says 84%, meaning what's the other 16%? So the other 16% meaning the other factors that can affect your dependent variable. So for example, in your grade, in your final grade, let's say quizzes has a coefficient determination of 70%, meaning there are 30% that is not accounted by the quizzes. So meaning there are other factors that can affect your final grade, meaning class standing, your finals exam, and many more. So this is what it means by the coefficient of determination. But our focus here is in the p-value. So let's take a look here. For our final p-value, that's 0.02. So that's less than 0.05. So if it's less than 0.05, so we reject the null hypothesis, meaning that the x and y variable have a relationship, significant relationship with that. Okay. So can we look at another problem? I have one more problem below. So let's see here. Let's use number 4th problem here. So percent of working versus percent of management. Percent of working and percent of management. Okay, let's copy 67, 45, 73, 54, 61. For management, 49, 21, 65, 47, and 33. So my question to everyone here, so based on the two variables given here, which do you think is your independent and dependent variable? Is it percentage of women working in the company? Or is it management, percentage of management? What do you think? Hint. If you read the problem, it's already giving you clues. Okay, I'll take a look at your questions later on, Miss Denise. Okay, so as my question earlier, which do you think is your independent dependent variable? Is it the percentage of management or percentage of management? What do you think? Yes? NAD, yes. So if you were to read the problem, so the following data gives the percentage of women working in 5 companies in the retail and trade industry. Percentage of management jobs held by women in each company is shown below. So if you read letter A here, it's already giving you the hint. So develop a scatter diagram that this percentage of women working in the company as the independent variable. So percentage of women working is your independent. So that's your X. as your percentage of management is your dependent variable. So let's test the relationship, see what's the outcome. So go to regression again. In this case, our dependent variable is management, okay? And your independent variable is percentage of women working, okay? And then check the box for labels, output range. So let's stay below. Decide to do it and select OK. Okay, so let's take a look again on the descriptive statistics here. Okay, so based on the correlation coefficient, again, it shows a very strong relationship between percentage of working versus percentage of management. And if you take a look at the correlation coefficient of determination, it also shows a very strong impact, 72%. And then based on the p-value, which is greater than 0.05, what does it mean? So the conclusion here is that there is no significant relationship between percentage of women working versus the percentage of management. Okay? So does it make sense? So the percentage of women has no impact in terms of people working in management. Maybe what does affect is the competency of the person in management. Obviously, to be able to work at the top, you have to have the general competence. Does it matter if you're a male or female? Right? But based on our data here, we can safely assume that part. Okay. So, any questions so far? Yes. Thank you very much, Denise. So, just to go back. So, if you notice here, regression is a very powerful and useful tool in terms of research, of trying to understand relationships. Now, obviously, we've done several tests today, but one word of caution. So if you were to go back, let's go back to the data here. And you can see here, based on our analysis, look at the observations. How many observations were we able to collect data? So our assumption, our test, our conclusion is based on the number of observations. In this case, there were only 5. Now, how accurate is your analysis based on the data collected? May be questioned. Because is 5 a representation of your entire population? Maybe not. So if you have a very big population in tens of hundreds or even millions, then maybe you need to collect more data. But if your population is a smaller group, let's say you have only 10 in your group, then 5 maybe is a good representation. Right? So always be cautious in the number of samples. That's why in your assignment, the number of sample size collected is critical in terms of getting a reliable outcome. So the more sample size that you could collect, the more reliable is your result. So this is regardless what type of test you're doing, whether it's z-test, t-test, f-test, or even chi-square test. Whether you're comparing one groups to multiple groups. So at the end of the day, sample size do matters because if you want your results to be, to be accepted, so you have to follow the requirements in terms of statistical processes. Start with sample size, what are the processes involved, and so forth. You will encounter this once you've gone through your thesis, thesis 1 and thesis 2. Okay, so any questions so far? Let's see any questions posted, comments below. Okay, so any other questions regarding today's topic? So is it clear regarding the differentiation of what your independent and dependent variable is? That's the only main concern you have to worry about, especially when you're talking of regression. And our coverage will all tackle linear regression. So you have to only identify which is which. Because if you input your independent variable to your dependent and vice versa, then you'll get a different result. Okay? So just to go over something before we conclude our today's session. So we've already discussed the quiz for quiz 2 as mentioned. For quiz 3, which will be next Thursday, so I'll post the schedule. So our coverage is up to today's topic, up to linear programming. So can I get feedback also if you need to add one more session before we proceed with our third and final quiz? You can email me or send your chat here. Anyway, And finally, regarding your assignments, so as mentioned, you're given three options here. So you can collect primary data for family business or collect secondary data. In terms of secondary, you can choose any other types of data already. And then the third option is do the alternative case study. So you have three options at your disposal. If you have any more difficulty or difficulty that you encounter throughout, uh, do let me know right away so we can make the necessary adjustments. As I mentioned before at the start of the stream, there will be no more finals exam. That's why the assignment is critical here. Now, as to the breakdown of grades, I'm still waiting for the update. I'll keep everyone posted once I've received the information. So the quiz is key, the assignment is key, and as I mentioned, the case analysis for those who haven't presented due to the lockdown, all you have to do is submit the requirements. All of it will be due by end of the semester. So that's by end of the month. Okay? So for the cases, so soft copy is sufficient. I think same goes for the assignment as well, since we won't be able to meet on face-to-face anymore. So everything will be done online. So soft copy is required for the case analysis, for the assignment, soft copies for both your final paper as well as your raw data. So I can verify if you done your analysis correctly. So any more questions? So as I mentioned, just to clarify, there will be no more finals exam for the SI rating. Now, I don't know for the other subjects, so you have to confirm with your professors and verify. Okay? So, any more questions before we end the stream? So, regardless if the lockdown will be lifted by next week, so our objective here is not to finish the semester online. So just bear with the requirements. So if you encounter any problems, as I mentioned, keep reiterating that. Just email me right away so we can deal with the problem. Now, do you know anyone here who hasn't taken the exam? So please inform them that they need to take the exam so that they can finish the subject. So for those who have not submitted, okay? So if you have any group concerns, you let me know as well. So as I mentioned, for the assignment, there are only two things you need to do, regardless whatever, if it's the option one, which is the family business, or to find another different data set, secondary data, you just have to analyze it. So collect the data, at least 30, or you can get more, and then do the analysis. So I need to verify if you've done the analysis properly. So use the case format assurance basis. So look at the data. What's the problem? What's the objective? What's your alternatives? And what's your recommendation? Similar to the case analysis format. So it won't be too difficult for everyone if you've been following our discussion throughout the semester. Okay? So it's up to you how you analyze it. That's why you have a wide array of tools to describe your data, from using tabulation, graphical, and numerical measures. So it's up to you. Obviously, the more comprehensive the analysis, you get a better understanding what the data is all about. So you can make a better alternative courses of action and find a recommendation. Okay, similar to what we did before. I think if you recall in the Pelican store, right? You're given a set of data, different variables. So based on the analysis, what's the objective of the Pelican store? To maximize profit. How do you maximize profit? By encouraging more sales. So how do you encourage more sales? This is where the recommendations comes in, or the courses of action. What can you do? Sell more products, advertise more, do this and do that, and come up with a final recommendation. Okay? Yes, the question regarding when do we use the F-test again? As I mentioned, so the F-test is done primarily on the analysis of variance as well as in regression. So it depends on the problem. So either way, you still use the F-test. So obviously for F-test to be utilized in ANOVA, you have to select the option in data analysis for either one-way or two-way ANOVA. And then for regression, you have to choose regression, but it uses the table in ANOVA to determine the final p-value. I hope that answers your question. Okay. So, any more questions? So, as I mentioned, summarize the after you answer the assignment. So, summarize in the final paper and then submit another soft copy of your raw data. And that's about it. And then I think I was mentioned the grade consultation will be sometime mid-May. I have to clarify with the schedule, but our goal here is to finish first our quiz 3 and submit all the requirements. And I'll update everyone as soon as I get more information. Okay? So if there's no more question, as I mentioned before, don't forget to leave a comment down below and hit the like button. So for more live stream videos, you can check out my other videos. So thanks for watching. I'll see you in the next one. Bye. Okay, any more questions? Okay, I'll see everyone in the next one. Thank you, Juno. Thank you everyone for joining me today. You're welcome. And also stay safe. Enjoy the rest of the week. Enjoy Happy Easter. Bye.